Now that we know what the graph of y equals x squared looks like, we can take translations of that graph and we can apply rules we learned back in chapter 2 to figure out what the new graph will be. Now, if I was doing this for the first time with you guys, we would do things like look at y equals x squared plus 1, or x squared minus 1, or look at y equals x plus 1 squared, and see what these different graphs look like. Kind of take it slow like that. But the truth is, you guys already know how to do these problems because we did the same process back in chapter 2, except then we did it with absolute values. The same rules we learned then are going to work now. So first of all, this form written in red right here is called vertex form. That's vertex form for a quadratic. It's another way of writing it instead of standard form. Standard form was ax squared plus bx plus c. Vertex form looks like this, and you can see two examples of it right there. As of right now, we don't know how to put things in vertex form. If I give you something in vertex form, you should be happy because it's not bad to graph at all. But if I give you something in standard form, we don't know what to do with that yet. We're kind of starting out like this. So anyway, when something's in vertex form already, life is good because graphing these uses rules you guys have already learned. The first thing you're going to want to do when you graph a parabola is figure out where the vertex goes. If you don't know where that is, you can't really make the graph. And if you look at this, the vertex was at 0, 0 on the parent function we did in the last video. This guy is going to be moved right 1, up 3, using our rules from earlier in the year. Inside is left, right, outside is up, down, so that's a right 1 and up 3. So I want to put my vertex right there. Now typically, on a quadratic, what you would do next, on an absolute value, what you would do next is look at the number out in front, and that would tell you your other points. So in this case, we have a -2 out front. That still actually does give us our other points. So just like with absolute value, we would go down 2 over 1 in each direction, and we're going to get our points. Now if this was an absolute value graph right here, these were bars, we would make a V and we'd be done. This has a squared in it though, so we know it's going to be a parabola. The process, all that really means for us, is when you draw your graph, just make it curved instead of making a V. So that is going to be our graph. Now, the down 2 over 1, following the A, that trick works really nicely for the first point on either side. If I went down 2 over 1, it's going to work out really well. Now, if I do that again though, and I go down 2 over 1, I'm not on the graph anymore. This little trick only works for one point in either direction, because it's not, if you kept doing it, it would make a line. So, lucky for us though, all we need is 3 points, like we learned in the last video. So this trick will still work very nicely for us, which makes life really simple. On our next example here, this graph has been moved left 4, down 1. So I'm going to go left 4, down 1. There's my vertex right there. The number in front on this one is just a 1, because there's nothing there. So I'm going to go up 1 over 1 in each direction. And the only difference again, instead of making a V for an absolute value, I'm going to make myself a nice looking parabola here. There's my graph, and I'm done. I could go ahead and have you guys list the vertex, axis of symmetry, domain, range. I'll probably have you do that on problems you do in a quiz or test, but for right now, we're just practicing our graphs. I want to do one more problem in this video, and this is one where it is slightly different. There's something to remember, so I want to make sure you guys see that. So, the process on this problem right here, we have a -1/2 out front, is still start the same way. You're going to draw yourself a graph, and you're going to mark the vertex. So I have my axes right here. I know I'm going to go left 2, down 3. Left 2, down 3 places me right there. Now if this was an absolute value graph, I would go down 1 over 2, and I would be done with my problem. The trouble with that is, that does not work in this problem because that little trick I showed you guys where you get the other 2 points only works when you go over 1. What I mean by that, if this was like a -1 out here and just -1, I would go down 1 over 1 and I'd be good to go. I'd put dots here. If I follow this as is though, it's going to be going down 1 over 2. Once you pass that first spot over, it's not a line anymore. You can't follow it like that. That'd be like following it twice like I did before on the last problem, and I showed you that didn't work. So basically, the important thing to know here, just a note to write for yourself, when A is a fraction, so A being the number out in front of the parentheses here, turn it into a decimal. And then our trick will still work. So, in my problem right here, I have a negative 1/2. Negative 1/2 is the same thing as negative 0.5. So instead of going down 1 over 2, not allowed because I went over 2, what I'm going to do here is go down 0.5, or down a half box, over 1. And if I do that, I go down 0.5 on either side, I can get my 2 points that way, and my graph is still doable. So bottom line here, if you see a fraction out front, turn it to a decimal, and just go down by whatever decimal you end up getting. That is vertex form, and it's my favorite way to graph parabolas because it gets to be very quick.